Dear to lecture and fellow friends, we are from Group 3 and my name is Xiao Yiping. Today we would like to present on the proposal of the low melting point active ingredient for herbicides and pesticides. Next, here is a table of content which contains 4 chapters of this proposal. Next one, for chapter 1, product survey and the business models. For introduction of pesticides. Pesticides are a substance that are used to manage, eliminate and stop the spread of a pest and undesired plant and animal species. Pesticides are used to increase the farm produce as well as the storage and the delivery of harvest goods. They also apply to the animals to manage the infestation of insects, spiders, and other pests. For next one is a market survey for the pesticides. The global crops protection market chemical market was 57.13 billion USD in 2020, and the market is projected to grow from the 59.41 billion USD in the 2021 to the 81.74 billion USD in 2028 at a CAGR of the 4.66% during the analysis period from 2021 to 2028. And the herbicides segment is dominate the global market with a record of a 40.14% market share by type in 2020. In as many developing countries, including China and India, they are facing problems of the shortage of laborers for mechanical weeding. And the Asia Pacific is the largest market, which record the market size of 16.54 billion USD. And the key industry player as a Bayer crops science from the Germany, SETK AG from the Switzerland, and BASF from the Germany and others. And here is a customer needs, and we have classified the customer into 3 basic criteria. The first one is the basic quality, expected quality, and exciting quality. And here is the attributes and the technical requirement for each attributes. Next one is the house of quality, and the legends show that the correlation for positive is a negative and no relationship between the technical aspect, and also relationship which 9 is represented strong, and 3 is a median, 1 is weak, and 0 is none. And then for competition, the 5 is best, 3 is median, and 1 is worst. And also our product is compared to the 3 others competitor, Bayer, SETK AG, and BASF. Next one is BMC for this business canvas models for pesticides.
Hi, I'm Yiling, and I'll proceed with the explanation of product design. The problem formulation is to develop a promising solid formulation of active ingredients for herbicides or pesticides. The active ingredient should be easier and less hazardous to handle. It should have less safety and environmental impact as well. The problem can be transferred into the following needs and target properties: easy to handle, less safety impact, solid state at room temperature, dissolve quickly in water, ability to destroy or hinder pests, fast acting, and also remain effective for a long time. To design a solid active ingredient with low melting point, the melting point should be between 298 and 373 Kelvin, and the boiling point should be greater than 400 Kelvin. On the other hand, the toxicity should be between 1000 and 2000 mg per kilogram to generate active ingredient with slightly toxicity. Since an active ingredient that is soluble in water is needed to be designed, the water solubility at 25 degrees Celsius should be greater than 100 mg per liter. The table shown here is a mini database for the formulation of herbicides or pesticides. It usually contains 5 to 25% of active ingredient and also 75 to 95% of inner ingredient. These are the target properties value which will be inserted into ProChem for property constraints, including molecular weight, melting point, boiling point, and log value of water solubility. For the structural constraints, herbicides active compounds are usually acids of ester or salts. The following slides show the generation of solution through ICAST software. Firstly, the active ingredients must have an ester and acid functional group with chlorine. The number of groups were set between 2 and 6. The number of functional groups and number of same functional groups were set as well. After that, the property constraints were inserted into the system. The result shown here is the summary of the candidates generated through the software. It can be found out that a total of 25 candidates were generated. After this, I'll pass to my teammates.
Hi, I'm Kayi. After generating a total of 25 candidates from the software using the structural constraint we set for the molecule, here are 10 of the candidates that we obtained. Next, we are going to select the best 3 candidates among these 10 possible candidates. There are some properties that will be considered. Firstly, oral toxicity. This is to avoid producing pesticide that is highly toxic, which can cause severe symptoms of poisoning with a small dose. In order to produce active ingredients with slightly toxic, the value of oral toxicity must be greater than 500 mg per kg, while a moderately toxic active ingredient will have a value between 50 to 500 mg per kg. Another property considered is inhalation toxicity. Active ingredient with inhalation toxicity greater than 20 mg per liter is classified as relatively non-toxic. If the value is between 2 and 20 mg per liter, the pesticide is slightly toxic. Besides that, melting point, boiling point, and solubility are considered as well. Hence, by considering all these properties, active ingredient 6, followed by active ingredient 2 and active ingredient 1 are selected as the best 3 candidates, since they have higher value of oral toxicity and inhalation toxicity, which indicate that they are less toxic among these 10 candidates. Apart from that, they have a lower boiling point and melting point and relatively high value of log WS, indicating that they have higher solubility. Let's move to the property model estimation part. Firstly, identify the functional group for the selected active ingredient. Next, determine how many groups of each type are needed to represent the molecule. After that, retrieve parameters from the model parameters tables for the properties of interest and sum up the contribution. Repeat this step for the other active ingredient, which are active ingredient 2 and also active ingredient 1. So now, we are going to calculate the normal boiling point and normal melting point for the best 3 candidates selected. Here are the formula that we use. The constant value given are 222.5165 Kelvin and 145.5706 Kelvin respectively. We substitute the sum of the contribution calculated before this into the formula, and we get the estimated normal boiling point and melting point for each active ingredient selected.
I'm Sinlei, and I will continue to discuss task 3, which is economic analysis. First is the cost estimation for the product, and this is the assumption for it. The desired volume for pesticide is 1 liter, and the currency conversion from 1 USD to 1 ringgit is 1 to 4.28. This table shows the price for each of the raw material, and the total is 18 ringgit and 70 cents. To cover up the expenses, the profit margin is set to be 170%. Thus, the selling price is 51 ringgit per unit. Next, for the estimation of IRR, here shows the assumption that should be made to calculate the IRR. The annual sales are 100,000 units. The annual advertising cost is 200,000. Development cost for 1 year before launching is 400,000. Equipment cost is 500,000, and it can be sold at 10,000 after 3 years. Tax rate is 40%. Annual fixed cost is 200,000 for the rental fee, wages, and others. The NWC is about 25,000. For the bank interest rate, it is about 3%. The RM in thousand, and the red color values indicate the negative cash flow. This is the depreciation values for the equipment, and this shows the project cash flow. By using this equation, the rate of return can be calculated by setting the NPV value equal to 0. IRR is 5% that greater than the bank interest rate, and thus this project can be carried out. Besides, we have calculated the payback period based on the cumulative cash flow that's shown in the table just now. By doing the interpolation, we get that the payback period is equal to 0.07 year. From this graph, it can see that the period falls between the year 0 and 1, which closest to 0, and thus the payback period equals to 0.07 year is justified.
Now let's talk about the sustainability. For socials, our product always put through safety testing with organizations like Series. We also contribute to the society with financial support from time to time. For economicals, we will do sustainable innovations and having our product at reasonable price. Inside our product, we have a low melting point active ingredients. For environments, thermoplastic is used as the body of the product as it is recyclable. We will have less packaging in our supply chain, more packaging made from the recycled material. Next, there are two sustainable development goals in this project. First is the goal 12, responsible consumption and productions. In order to achieve this goal, our product development use recyclable materials. Next is goal 1, no poverty. The use of pesticides help to develop the agriculture sectors and increase the farmer income. In order for our product to be sustainable at the market, we will carry out the expert market research on the competitors. We will also take into account our consumer perceptions. Lastly, we will sell the products on the internet. To conclude, in these proposals, we have managed to design a low melting point active ingredients for herbicide and pesticides. And these proposals is also in line with the Sustainable Development Goals. That's all from us. Thank you.